Good afternoon to you all viewers. You're welcome to the second session. We are now looking at item 2 under the UNEB paper, which was done on 14th of October 2024. So this time round, we are basically looking at the topics where item 2 is derived. Remember, item 2 is under the compulsory items that a candidate is expected to do. Item 2 is derived or constructed from the theme that combines all topics under patterns and algebra. When you look at the topics under patterns and algebra, we have sequence and patterns. We have equations of a straight line, algebra 1 and 2, mappings and relations. We also have inequalities and regions, quadratic equations, linear programming, composite functions, and loci. So these are the topics basically that we use to construct item 2. And for this item 2, we normally don't use all the topics. We just choose some of the few to make up an item. When you look at item 2 of UNEB, it says, the scenario says that a tailor makes school uniforms for boys and girls. The tailor makes at least 80 sets of uniforms for boys and not more than 100 sets of uniforms for girls. Each set of uniform for boys requires 4 meters of material, and each set of uniform for girls requires 3 meters of material. The tailor has at most 600 meters of material to use. The tailor makes a profit of 8,000 Ugandan shillings on each set of boys' uniform and 6,000 Ugandan shillings on each set of girls' uniform. The tailor is not sure of the number of sets of uniforms to make in order to maximize the profit. Under the tasks, we have express the tailor's condition as inequalities and equations. Part B, show the feasible region of the tailor's conditions on a Cartesian plane. Part C, we have help the tailor to determine the possible number of sets of boys and girls uniforms that should be made to maximize the profit. Hence, state the maximum amount of money the tailor is likely to make. Now, when you look at item 2, it encapsulates some of the topics from this. It has some linear programming, generally linear programming. But when you look at part A of the task, it wants us to form inequalities. And these inequalities are linear equations. So when you look at it, we have inequalities, and finally we shall look at the region. Then it consists of some algebra and still equations of a straight line, as we shall see. So the first thing is that we don't have the variables. So what we need to do first is to let. So we shall let x and y represent the number of school uniforms for boys and girls, respectively. So here, a candidate should know that we let the variable to be what we need to find, the number of uniforms for girls. Don't say, let the uniforms for boys be X or be represented by X. No. The thing is, should be, let X represent uniforms for boys, let Y represent the number of uniforms for girls. So when you go back to the scenario tells us the number of school uniforms for boys should be at least 80. And at least means that this number which we have let, which is X, should be greater or equal to 80 because of what is in the scenario at least, which means greater or equal. Then we have the ones for girls shouldn't be more than 100, not more than 100. So we have y less or equal to 100, not more than. So when we are looking at the uniforms, each uniform for boys is made using 4 meters of material. And each uniform for girls is made using 3 meters of material. But a combination should not exceed 600 meters of material. So in actual sense, we have 4x plus 3y shouldn't be or shouldn't exceed the 600 meters of material. And as we know, we can never have the number of uniforms as a negative. So in actual sense, the uniforms we should either have uniforms for boys or have uniforms for girls. So we shall have x greater than or equal to 0, then y greater than or equal to 0. So this is part A of the scenario of item 2. So this part A, you realize that we have formed the inequalities that are needed, and these inequalities are basically out of the scenario. Each, once we say 80, at least 80, it should be greater or equal. Once we say not more than 80, it can be, sorry, not more than 100, it can be 100 or less. Then here we now analyze the materials being used. So these are inequalities, and it takes us to inequalities and regions. Still, within the inequalities, we are going to form some equations of a straight line that are going to help us to analyze this. Now, when we talk of the profit, we are saying that profit is equal to 8,000 x plus 6,000 y. This is what we want to maximize. So we want to get the number of uniforms for both boys and girls that can help us to maximize the profits. So this is our objective function, and we're going to use this objective function after analyzing the problem that we have. So the next thing is now representing it on the graph, which is part B of the item. So part B of the item, putting it on a graph, we need to first analyze each of these inequalities and form linear equations. On forming linear equations, we shall use a table, and then the table will help us to plot them. So let's see how it is done. When we look at x greater than 80, greater than or equal to 80, it is the same as x equals 80. So you can identify this line on a Cartesian plane. So this is a solid line. Then we also have y is equal to 100, and we have less or equal, which calls for it to be also a solid line. Then we have 4x plus 3y is equal to 600. This is also a solid line. So when you look at these two, they are equations which are direct, which can be directly what? Plotted on the graph. But when you look at this, it has two unknowns. The two unknowns, normally the best way of drawing such is just by drawing a table, come up with the coordinates, and then plot them on it. So we have this table. Have x, y. So here a learner can randomly choose the values of x or the values of y in order to just formulate a coordinate. So if as at all we say when y is 0, we can place the y here. So we shall have 4x is equal to 600 divided by 4 divided by 4. Then this gives us x as 150. So whenever y is 0, x is 150. So this gives us a coordinate, which is 150, then x, which is 0, y. Then we can think of some other value. The other value can be at random, so long as it can be plotted. So we can say when x is 0, we put the 0 here. So we shall have 3y is equal to 600, divide both sides by a 3, then this will give us a 200. When you divide 600 over 3, you'll get 200. So we place it here in our table, and this forms for us a second coordinate. So this second coordinate will be 0, then 200. So any two coordinates can help us form the equation of a line. So the next thing is that we are going to place this on a Cartesian plane. Part A of our item 2 was telling us to write down the inequalities. And these inequalities, we have written them down, and now we have summarized them. We have put them into linear equations, and these linear equations can be represented on a graph, and by shading, that's when the inequalities will come in and the regions will come in. So this is our graph paper, and on this graph paper we need to choose a scale depending on which point is highest. Which value of x is highest? It is 150. Which value of y is highest is 200. So from these we can now draw these lines. When you look at this x is equal to 80, we are saying it is a solid line since it has less or equal. When do we use solid lines? When do we use dotted lines? We only use dotted lines if we have an open. Let's say less and greater. Here we use a dotted line. Whenever we have less or equal, then greater or equal, that's when we use a solid line. When we analyze this, it was x less or equal to 80. That's when it came up to a solid line. We had y less or equal to 100. It came to a solid line. All of them had the equality on them. That's why they became solid lines. On sketch drawing these lines are simpler. That's why for them they are like this. But when you go to two variables within the same equation, that's when we draw a table to come up with it. Any two coordinates. Some people always have an option of having so many coordinates, but the best way is having two coordinates. So let's start by drawing the axes. By drawing the axes, we start with the y-axis. Then we also label it. Then we draw our x-axis. So this is our x-axis. We also label it. So after labeling it, always don't forget the heading. Under this, we are looking at the number of uniforms. We want to compare which number of uniforms can give us a maximum profit. We are doing this because the tailor wants to know the highest number of uniforms that can be produced for boys and girls that can yield to a maximum profit. This is an application question. So when we look at this, we need to choose a scale. When I choose a scale, the scale will differ depending on what one wants. Someone can use a scale of 1 centimeter representing 5, 1 centimeter representing 10, so long as it fits on the graph. So we shall start with 0, then 10, then 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, then 150, then 160. You realize that along the x-axis, we have the maximum value, which is 150, so it has been also encapsulated into on our graph. Then when you look at the y-axis, our maximum is 200. So we can also utilize that. Here we can use 20. So we also have 0, 20, 40, 60, 80, 100, then we have 120, 140, 160, 180, 200. and then we have 220. We can stop there because already the 200 is within. So the first thing to do is let's draw these lines, which are simpler to handle. But for each line that we draw, we are going to test and shade it. Don't wait to draw all the lines, then you shade them. It can create some confusion. So whenever you draw one line, shade it, check, and then you shade it. So we are starting with x equals to 80. And on the x-axis, that's where we have x values. So when we say x equals 80, we locate on the x values where 80 is, and we draw the vertical line. So we are going to draw this vertical line like that. And it should be a solid line. So we label this line as x equals 80. So after drawing this line, we have values of x this side. So we want to test. Depending on the inequality that we have x greater or equal to 80. So testing this means that we need to have the values of x. When you look at 80, never test using the value itself, which is 80. You can either choose the one below or choose the one above the line. So we can choose the ones beyond 80. Let's say x equals 90. Now our question will be the chosen value of x, is it greater than 80? So we're asking ourselves, is the chosen 90 greater than 80? Which is a yes. And it means that the 90 that we have chosen is in the side which obeys the inequality. So where 90 is, this side obeys the inequality. Let's say when you choose values which are less than 80, let's say 70 now. Is 70 greater than, we are still maintaining the same inequality, is it greater than 80? And then it is a no. Remember, we are looking for the wanted region by shading the unwanted region. So when you look at this 70, it can't be greater than 80. That's why we have a no. Is 70 greater than 80? No. Then it means that this region where 70 lies is the unwanted region, and therefore we shall shade that region like that. So this is it. So this is what we have. Then now we go to the next, which is y is equal to 100. And for y is equal to 100, we do the same. We look for y values. Where we have 100, which is this, we draw a horizontal line for y values. So this horizontal line will be like this. For y is equal to 100. So that's where we are. So we have y is equal to 100 there. So we also do the same to test the nature. So for this y is equal to 100, remember its inequality. Its inequality was y less than or equal to 100. So we need to base on this to test on which region we should shade or not. So when you look at this line here, we have values of y below it and values of y above it. So we pick any one. So when you choose, let's say 60, we ask ourselves, is 60 less or equal to 100? And what will it be? A yes. It means that the region where this 60 belongs is the wanted region because it obeys the inequality. So where this 60 lies is the wanted region. So let's test for something above 100. When we come to our graph, we have 120, 140. You can choose any two. We ask ourselves, is 140 less than 100? Is 140 less than 100? And it's a no, because 140 cannot be less than 100. And therefore, we can shade this region here, which is the no. So on shading it, we have something of this kind. So we go to our third, which is 4x plus 3y is equal to 600, and we obtained these two coordinates. We plot them. We have on the x-axis, we have 150, and on the y is 0. So it will be like that. Then we have 0, 200. 0 on the x, then 200 on the y. So we have that. So we use a ruler to join the two points. So we shall have this like that. And then it will come to this. Then we label that line to be, it is 4x plus 3y is equal to 600. There is a common mistake that is always made when students are labeling these lines. They normally want to put inequalities, but these are lines. When we draw just a line, the shading will already show that it is a line, but at the same time an inequality. It was derived from an inequality. So as we continue to analyze this, we are going to choose, this is our line, which we have labeled 4x plus 3y is equal to 600. And therefore we need to shade it. We need to shade the unwanted region. So we choose, we have values, we have this region, this side of this line, and we have the region which is above the line. So you can choose coordinates from anywhere. From this, you can choose only one coordinate, test it. Is it a wanted coordinate or not? What we mean, does it obey the inequality or not? That's what we want to see. The easiest way, if the line is not passing through the origin, the best way is to choose the origin as the coordinate that we are using to test. So we had 4x plus 3y. So here we are testing is less than or equal to 600. So from this point, we test using 0, 0. Now it's a coordinate since we now have two variables within the same equation. When you look at these two, we are using only the value of y since we had only y in the equation. For x, we used only x value since we had only x in the equation. For this case, we have two variables, x and y. So if we use a coordinate. So when we say 4 times 0 plus 3 times 0, is it less or is it less than 600? So is 0 less than 600? And it is a yes. 0 is less than 600. So it means that this part here, where we have chosen a coordinate as 0, 0, is actually the wanted region, and therefore this side becomes the unwanted region, like that. So the next thing is now analysis of these two. When we say the line x equals 0, the line x equals 0 is the x-axis, sorry, the line x equals 0 is the y-axis. And we say that x is greater or equal to 0. That was the inequality. So this means that this inequality obeys those values of x which are more than 0. So it means that those values of x which are more than 0 are in the wanted region. So in actual sense, we shall shade this side because we can't have number of uniforms as negatives. Then we go to y equals to 0. Y is equal to 0. Its inequality was the number of uniforms for girls should be more than 0. They can't be negatives. So in actual sense, we go to this point where we have this line. This x-axis is the line y equals 0. And when we look at the values of y which are more than 0 are these values. So it means it obeys the inequality, and the number of uniforms for girls can't be negative. So our feasible region is what is formed here by those boundary lines, like that. So it means that the number of uniforms that we are going to choose will depend on what, because all the constraints have been utilized and they are bounding the problem to this, and therefore we need to choose within this which number of uniforms for both boys and girls can actually maximize the tailor's profits. So in actual sense, whenever maximizing and we have all lines solid, it means that we can always choose at any point along the lines and at the corners of the boundaries. Or we can even choose inside. But if at all they are dotted lines, we cannot choose points along the dotted lines, or at a point where a dotted line meets a solid line, or at a point when a dotted line meets a dotted line. We don't consider those points. We only consider points where a solid line meets a solid line. So we choose the first point. When we're choosing the first point, we can see that we have 150, 0. That is the first coordinate, which we are going to take and then analyze it to see the profit that it will give us. The second point, we can have, along still this line, we can have 0, 145. We can have also 0, 130. So we choose points along that within the feasible region. So we can have all these points chosen. Then test it in our objective function to see which profit they give us, and from there we can choose our maximum profit. So we choose all these boundary points, making sure that we do not have decimal points, because when we are analyzing these problems of linear programming, they are real life situations of which you can never have half uniforms or 0.5 uniforms. 10, we should have whole numbers. That's why we always need to neglect the decimals within. We pick whole number points, integral points from the feasible region. So now, as we continue with our item 2, having drawn on the graph to represent the feasible region for part B, part C wants us to find the maximum number of uniforms that can help the tailor get or earn a maximum profit. We don't just think of it, we just use the feasible region that we have got, because these constraints are bounding us to a specific number of uniforms that can give us the maximum profit. So we choose points from this region and we choose whole number points. When you look here, we have extracted 150, 0, 145, 5, 135, 20, 130, 25, 165, 115, 45. Make sure that you try this on a graph paper and comment below. Like the video, download the CATD app for more material. So let's progress. When we look at this, we have our profit, which is the objective function. This objective function, we are going to substitute the value. So whenever we have produced a maximum of 150 uniforms for boys, girls may not have anything. So we shall now compute and have 8,000 times 150 plus the 6,000 times 0. This will give us 1.2 million. 1.2 million Ugandan shillings. And then when we compute this 145 boys, number of boys uniforms, 8,000 times 145 plus 6,000 times 5, this will basically give us 1,119,000. So we progress by having 8,000 times 135 plus we have 6,000 times the 20. So this will also give us 1.2 million. Then we also have 8,000 times 130 plus 6,000 times 25. When you press the calculator, this will basically also give you 1,190,000. So we have also 8,000 times 100 plus 6,000 times this value here, which is 65. This will give us 1,190,000 shillings. So this will also give us 8,000 times 100. We had made some mistake here. When you compute, it will give you 1,190,000 shillings. So we also compute for 115 and then 45 in our formula for the profit, and then we get 1,190,000 shillings. Now here, as a candidate, you need to choose which one is the maximum profit after looking at testing for all points within the feasible region. But when you're testing for all points within the feasible region, you have to look at, as you go far away from zero, that's when you can get the maximum. If at all you are looking for minimum, you look for points which are a bit closer to zero, but still within the feasible region. Now, if at all you want the minimum, you look at points within the feasible region, but more closer to zero. So now, here, you need to be keen on which one you are choosing to be the maximum. When you look at producing 150 uniforms for boys and 0 uniforms for girls, or no uniforms for girls, it will give you a maximum profit of 1,200,000 shillings. Still, when you produce 135 girls uniforms and then 135 boys uniforms and 20 girls uniforms, you still get a maximum profit. But all of them we can't have two maximum values. So we need to choose the best. The best of this is that when we are talking of the certain school that the tailor is making, we didn't say that the school was a single school. It is general. So what we shall say the tailor has to produce 130, which is 135 boys uniforms and 20 girls uniforms in order to make a maximum profit of 1,200,000 shillings. In order to make a maximum. So that is what we have. So there are two options. A candidate can say you can produce 150 for boys and nothing for girls, but the best one would be this. We are producing 135 uniforms and 20 uniforms. Otherwise, even if you had stated for the first one, you can still earn your scores. Thank you so much for watching. Subscribe, follow, and like for more. And you can go to Play Store to access our app, which is KTD app. For more information, it has some games, some new curriculum style questions, and then some guiding notes from Senior 1 to Senior 4. For now, every subject is there. Thank you so much.